Hi, in this video we're going to learn about Pythagoras Theorem. Pythagoras is one of the most famous ancient Greek philosophers who lived 2500 years ago, and his most known work is the Pythagoras Theorem, and he has other works on maths, generally in geometry, politics and religion too. Basically, the Pythagoras theorem says there is a relation between the sides of a right triangle, which could be written as c squared equals a squared plus b squared. Now, in several books, you may see different combinations of these letters, right? It could be a here, b here, c here, so it will change, like a squared is b squared plus c squared. Basically, it doesn't matter. What letter you use does not matter. What matters is that you have to know that the sum of the right sides, meaning the sides which have right angle between them, the sum of the right sides squared is equal to the square of the longest side, which we call as hypotenuse. So this side, the longest side, is always across the 90-degree angle. So this is the longest side called hypotenuse. It's always across the 90-degree angle. And that is the one which will be isolated, right? So this is the formula, if you'd like to say, of Pythagoras theorem, which states that the square of the longest side is equal to the sum of squares of the right sides. Okay? Let's see an example. So let's try to find the side length of this side, right? So this is actually across the 90-degree angle, so this is the hypotenuse, right? So this must be the isolated one, so it must be x squared equals, now it's 3 squared plus 4 squared, right? And which would give me 9 plus 16 and 25 eventually, right? At this point, I'm just going to take the square root of both sides to just find that basically x is nothing but 5 centimeters. So this is a Pythagorean trio, let's say, or triplet. These numbers, 3, 4, and 5, the biggest being the hypotenuse, these are the integers that fit into Pythagoras theorem. So there are those more of those trios, right? So it could be 3, 4, 5. It could be the multiples of 3, 4, 5. Like if you expand everything by 2, it's going to be 6, 8, and 10, right? It could be, if you expand it by 3, so 3 times 3 is 9, 3 times 4 is 12, 3 times 5 is 15. So these trios all fit in or satisfy this theorem, right? So let's see another example. In this one, we have 5 and 12 centimeters. Notice that the angle in between is 90 degrees. So basically, these are the right sides, and across the right angle is hypotenuse. So I have to write down x squared isolated equals 5 squared plus 12 squared. You could equally write 12 squared plus 5 squared, which is the same thing. That's totally okay. So it's going to be x squared equals 25 plus 144. That's the square of 12. And you end up with x squared being 169, which is nothing but 13 when you take the square root of both sides. So basically, the hypotenuse is 13 centimeters. So this is another trio, 5, 12, and 13. So if you expand these, get the multiples of these, like 10, 24, and 26, and so on, you will still have these numbers satisfying the Pythagoras theorem. Right. Certainly not all the time you're going to get integers. You have 3.9 here, you have 6.1 here. The first thing, again, we have to find the hypotenuse, which is across the 90-degree angle, so that's hypotenuse. Right, so I'll go with x squared equals 3.9 squared plus 6.1 squared, which would be 15.21, and 6.1 squared is 37.21, and I'm going to have now the sum of these, which would be 52.42. That's x squared. Now I have to take the square root of both sides, finding x to be 7.2401, and so on. Well, if we'd like to round this up to 3 significant figures, we should be cutting it here from here, right? Cutting the number from here, and you get actually, right, 7.24 centimeters for x. How about this example? Now, regardless, if we have a right triangle and we are given 2 sides and we're asked to find the length of the third side, we will be using Pythagoras, right? So the first thing we're going to do again is to find the hypotenuse. Now, it is the side across the 90-degree angle, so this is the hypotenuse. Now, I have to write 10, the length of hypotenuse, isolated, right? It's 10 squared equals 8 squared plus x squared. See, this time we're asked to find the length of one of the right sides, yeah? But it doesn't matter. We can calculate the squares of these numbers, right? And then we could just solve for x squared. Basically, we're going to take away 64 from both sides so that we get rid of that and leave x squared alone. And 100 minus 64 is 36, where I'm going to take the square root and find that x is nothing but 6. Now, remember here, if we take the square root of any number, like 36 for example, we always end up with plus minus 6, because 6 squared is 36 as well as minus 6 squared is 36. But just because we are finding a side length which cannot be negative, we ignore this bit, right? We just say this must be positive, right? So we choose 6, or we choose a positive value, not the negative one. But this is how we solve for Pythagoras theorem if one of the right sides is asked. One more example. Right, we have to find x again. The first thing, I'm going to find which of these is hypotenuse. It's right across the right angle. So this is hypotenuse. This is the one that should be isolated. Right, so this is equal to x squared plus 7.2 squared. And let's calculate these. 272.25 equals x squared plus 51.84. And now I have to, well, you can use the shortcut too. Instead of taking away 51.84 from both sides, which I prefer, you can just take the number to the other side as negative, so it must be taken away, right? So I'll have now x squared equals nothing but 220.41, and then I'll take the square root of both sides and prefer the positive value. Well, the square root of this number will be 14.846, and so on. Again, 3 significant figures will do because we have only 1 decimal place here. So we can go 1 decimal place, 3 significant figures. It doesn't say. But the question sometimes will tell you what to do in terms of rounding, so you will follow their lead. So let's write with blue. That's x equals 14.846. 5.8 centimeters. So this is how we find one of the missing sides given the other two sides by using Pythagoras Theorem. Now is your turn. Please solve these questions on your book and submit your answers online. Now remember, if you need be, you can just round your answers to 3 significant figures. Thanks for watching.